Okay, in example 120, I want to graph the greatest integer function. And the greatest integer function is the function that's defined to be the function that eats any real number and rounds down to the greatest integer less than or equal to that real number. So let me start by just giving you an example. So an example would be like if x is 0, then what's the greatest integer less than 0? Less than or equal to 0, that'd be 0 still. So you get 0 zeros on this graph. And then if I put in like 0.1, the greatest integer less than 0.1 is still 0. If it's 0.9, the greatest integer less than 0.9 is still 0. But then when I get to 1, the greatest integer less than or equal to 1 is 1. So the idea here is that you get a constant flat line until you get to 1, and then you jump up to 1, 1. And then it's going to be a constant flat line until you get to 2 and you jump up. Like if you put in 1.2, what's the greatest integer less than 1.2? That'd be 1. If I plug in 2.3, the greatest integer less than 2.3 is 2. So again, you're just getting these little flat lines, and we call these step functions. And the idea is that you're just rounding down. And notice that on each interval, the left-hand endpoint is closed, the right-hand endpoint is open. And these step functions, or greatest integer functions, these sorts of things show up all the time in investment problems where you have compound interest. And so you might have a set investment, like the amount in your bank account stays constant for a certain amount of time, and then like every 3 months the interest gets compounded and the amount in the account jumps up. Okay, so that's one of the main applications of these greatest integer functions, or step functions more generally.